Hello, and welcome to the first of what would be many enjoyable video lectures on geography by yours truly, Jason. Okay, all kidding aside. Obviously, I would rather be lecturing in person. It's one of, I think, the more effective ways for me to deliver the material. This is a supplement for you, so these are the PowerPoints that I would be giving in class with me right here in the corner talking. Um, Use these as you will. A couple things to know. These videos are going to be about roughly 10 minutes each. I'm going to break them up into chunks. That way you're not watching a 45-minute video and falling asleep in the middle of it. You can watch them, take your time with them. We'll talk about more about that in virtual class. But let's get ahead and get started with Chapter 1, the home planet. And so the question I always ask is, what is geography? Specifically, I'm going to say this. Think about this question. If you had to define geography, right, how could you do it without using the word map? So geography without maps. Think about that one for a while. I could play the Jeopardy theme. And as you'll learn, we'll talk about that. The book says that geography, is a brief account of the planet we call home. I always think about it this way. If you think about the word geography, let me go back. Geo. Geo is the Greek word for earth. Graphy. The Greek word graph means to write. So geography at its heart is writing about the earth. Now, as earth is our home, that's a pretty broad statement. So it covers the physical geography, mountains and rivers and deserts, political geography, countries and states, economic geography, where money goes, follow the money train. You could do the geography of sports, which teams play in which countries or states, all of these things. Anything that involves space and place, we'll talk about that. Every one of the lectures is going to start with what these chapter learning objectives. I'm not going to read these to you because I'm assuming that you all are old enough to read for yourself. But this is just kind of a brief outline of what we're going to cover in this lecture. So they're just there for your knowledge. But let's get right started. So chapter 1, the book talks about the big picture, the Big Bang Theory. How did everything come to be, right? And the Big Bang Theory was a great TV show. But in this context, we're talking about this idea that everything in the entire universe, all the galaxies, all of matter, all of energy, begins at some point roughly 14 billion years ago as one point in space and time, which then expands or explodes, and the galaxies and the universe has been exploding ever since, right? They estimate about 13.7 billion years ago. I'm not going to cover too much more of this because this is geography class, not astrophysics. But if we're going to talk about, space and place, we got to start with everything, right? And to narrow down from the universe, we are in the Milky Way galaxy, which is just one of many billions of galaxies. Inside of our solar system, I was asked this question, how many planets are there? And usually the answer depends on how old you are. If you're my age, you're going to instinctively say 9. Many of you are probably going to say 8, right? Because you have this case of Pluto, right? So Pluto used to be considered a planet. Up until it was discovered in 1930, it was considered a planet until roughly about 2006. And what happened? In 2006, scientists said that it's actually so small, it's smaller than some of the moons of Jupiter. It's not truly a planet, but it's a dwarf planet, or Plutoid. I prefer the term little person planet, as dwarf is kind of offensive. That's just me. But you got to kind of ask yourself, right? It doesn't have the same type of orbit as every other planet. There are some points where it's actually closer to the sun than Neptune or Uranus. Sometimes it's further out. So it's also very small. There are a group of scientists who decided this. Now here's the question. Just because these group of scientists said that Pluto isn't a planet, does that mean that it's the truth, the gospel? You kind of have to ask yourself, who gets to decide these things, right? So the first of many bad jokes I'll make this semester, and trust me, I love nothing better than a really bad dad joke, is Pluto, right? When they discovered it in 1930, they had already built the planetarium in downtown Chicago, the Adler Planetarium. And they had engraved the names of all the known planets on the outside of its walls. So they never put Pluto on the outside because it was already made at the time. And they never fixed it. But that kind of worked out pretty well because now Pluto's no longer a planet. And now Pluto's only really just a really second-rate Disney character. So, please feel free to ignore my dad jokes. My wife and my son sure do. Also, when we start focusing in, let's talk a little bit about the Earth and the Sun. So hopefully you all are aware that we actually orbit the Sun. So you are not the center of the universe. That would be, or the center of the solar system. That would be the Sun. And the revolution is how long it takes to get around the Sun. It's also a great band from the 1980s with Prince as its lead singer. Again, another bad dad joke. But it takes 365.25 days to make one revolution around the Sun. Now, many people think that the reason we have summer and winter is that in the summer we're closer to the Sun because our orbit is not a perfect circle. It's actually slightly like an egg. Ironically, we are actually closer to the Sun in January than we are in July by about roughly 8 million miles, which is enough to be a difference. The reason that we have seasons is the tilt. So Earth revolves on its axis, right? It spins around. That's why we have day and night. But the Earth spins around an axis. The axis is not perfectly straight 90 degrees. It's actually tilted at 23.5 degrees. So what happens is, as it orbits the Sun, or revolves around the Sun, during the summer months, the northern half of the Earth is pointed more towards the Sun than the southern half. And so that basically gives it more sunlight, which gives it more energy, which gives it more warmth. That's the tilt that gives us the seasons. The rotations of the Earth, we talked about this, is the day and night. How long is a day? About 24 hours, right? Which gives us the diurnal cycle, which is just a fancy term for this idea of day and night, day and night. And the diurnal cycle has affected much of life. If you think about this, animals, or most animals, either have a nocturnal pattern where they are up at night and sleep during the day, or a daytime pattern where they sleep during the day. I just said that, right? So that affects your sleep patterns. Now, we're not going to cover it too much in this class, but they do think there are these slight variations. The orbit of the Sun, for instance, how we orbit the Sun, that tilt that I mentioned that gives us winter and spring, that it's at 23.5, it actually varies. It goes between 22 and 24 degrees over the course of 50,000 years. So very, very slow, so much we don't notice it. But if it's tilted 2 more degrees closer to the Sun, that tends to give a cumulatively warmer climate. And when it tilts away from the Sun, it gives us a colder climate. Also, the shape of our orbit. So I said that we're slightly oval. Sometimes the oval switches more this way, and sometimes more this way. And it takes roughly about maybe 50 to 60,000 years for that kind of flexing of the orbit to happen. So that, plus the tilt, just goes to create various amounts of energy from the Sun reaching us. Because the further we are, the less energy that gets to the Sun. And that's how we can explain the long-term climatic patterns that we've seen in Earth's history of ice ages. Again, we're not going to cover that too much. Another thing that's kind of talk about rhythms and patterns is that the moon and the sun combine to cause the tides. Now the moon's interesting. For a long time we thought the moon was just part of the solar system that had been formed the same time as Earth, but we now have found evidence to support that sometime about 3 billion years ago, a large asteroid smashed into the Earth so big that it almost broke it apart. And all of the broken parts of the Earth got thrown up into space and eventually formed the moon. But the moon actually creates the tides. Now, there is no tide on Lake Michigan, but if you've ever been near the ocean, the sea seems to rise and fall every 6 hours. And that's just basically the moon slightly pulling the water. And we're talking a very slight, maybe 2 or 3 feet lift on most parts. Okay. Also, it takes roughly 1 month for the moon to orbit the Earth. So if you've ever watched at night where you have a full moon where it's completely bright to where there's no moon, the new moon where it's dark, that takes 28 days for that cycle, the lunar cycle. And that was the original calendar for most of human existence. They would actually mark the start of a lunar cycle as a month. That's why to this day our months have usually 4 weeks and are close to 28 days. We switched over about 1,000 years ago to a solar calendar, which is a little bit more accurate, and I'll explain why. And they had to adjust the months and add a few days in there. But what's one of the patterns of all this? Think about the patterns of life, monthly, daily, yearly cycles, right? We know every season we're going to have a summer and a winter, and that affects your life in Chicago. You can't tell me that it doesn't, right? Um, Especially if you work in, maybe if you work in the tourism industry, right? If you are a tour guide or you work in retail, the time of the year definitely affects that. There's time of the year to go to school and time to not go to school. Daily cycles, right? Getting up, going to bed. One of the interesting things is that we've actually been able to track that some people are affected by this. So there's this disease or this disorder called seasonal affective disorder. It's basically a form of depression. And we find this when people are deprived of sunlight. So in the winter, right, the days get shorter and the nights get longer. And the farther north you get, the nights get even longer. Some parts of Norway and Alaska are so far north that during the winter, they maybe have 1 or 2 hours of daylight a day. And what they find is in those areas, there's a much higher rate of depression. And so, as a prescription, doctors actually tell people they give them a grow lamp, a lamp that puts out the same kind of wavelength as the sun, white light. And they say, sit under this lamp and read or whatever, but just sit in some more light. And it does lower their rates of depression. All right, so we're going to pause right here. This is part one. I know that you are just so excited for this part two to come up. So go ahead and go get yourself a snack, maybe a cup of coffee or some hot tea, and we'll start with part two in just a moment.